And welcome back to our Intro to Electronics series here at Microcenter. I'm here with Andy, and we're going to pick up right where we left off in the last episode. I have the project all set here with a couple of other things all laid out.
Right.
What did we do last time? We have this LED, right?
Yep. So last time we talked about components. We talked about that the Arduino is a microcontroller board. We talked about that a Raspberry Pi is a single board computer and what they're good for. So we're going to focus today in on what we did last week, which was make an LED blink and then also make an LED fade.
Okay.
And again, the circuit that we have here is relatively simple. We've got a signal coming out of ground to go to the ground of the LED. And then we've also got a signal coming out of pin 13 going through a resistor, because LEDs don't normally love 5 volts. I mean, they'll be okay, but it's better if we put a resistor in there. 220 ohms or 330 ohms is fine. And we programmed the board using the Cloud Arduino IDE, and we changed a variable to make it blink.
Okay. I remember all that, and it seemed pretty easy for the most part. So we're going to branch off of that, and we have all of these LEDs laid out here.
Yeah.
What are you thinking?
Well, I think we could do a Larson scanner. Now, a Larson scanner, if you're not familiar,
I'm not.
at least this is what I believe it is. Is basically like, are you familiar with the old TV show Knight Rider?
Ooh, yes.
Right?
Kit, the car.
Kit, yeah.
Yeah.
With David Hasselhoff.
Yeah.
Jinx. Anyways, so what would happen in the car is on the front, the lights would kind of go in and out or back and forth, right? So that's kind of the Larson scanner. There's also another sci-fi TV show, which is escaping me right now, where the robots kind of had these as eyes.
Oh, was it Battlestar Galactica?
Yes.
Is that the one? Yeah.
Bears beats Battlestar Galactica, exactly.
Yes.
So let's go ahead and build one of those today.
Cool.
And then program it. So first, let's focus on the circuit.
Okay.
I will see if I can find an easy circuit for that.
I'm just going to take a wild shot in the dark while you're setting that up.
Yep.
The way we have this set up, right? You know, we have the signal coming out, going through, and going back in. So what I imagine is we're going to have a similar setup coming out of the Arduino, running into the breadboard. Everything's going to run through, and then still have a termination at the end that's going to run back. Or is it going to be multiple connections going back to the board for each LED?
So
I guess how do you make each LED addressable?
In the case of simple LEDs, right, that don't have integrated circuits built in, we do have to address each one from a different pin coming from the Arduino. So,
Got it. Okay.
So we have, let's see, we have 0 through 13 just on this side in digital pins.
Okay.
I don't think we need to do that many. Let's do 6 to start. And let's talk about some efficiencies in setting up the circuit. I have a circuit here on the screen. So essentially what we're going to do is take all of these resistors and take the negative lead to a negative line here on the power rail.
Right, okay.
And we talked about the breadboard last time. And then we're going to take the positive lead and we're going to attach it through a resistor and to any given pin. So let's go ahead and start doing that.
Seems relatively simple. And the other thing is we have all of these resistors here, right? I have a good pile, but I think last time we were kind of playing it a little loose and just putting any old resistor in. But I think this time we want a little bit more control over which resistor we're using, right?
Yes. So if you're lucky, when you buy a kit full of parts, they will label the resistors on this little piece of paper that holds it. Today we're not lucky, which is good because it means we're going to learn something. And that thing that we're going to learn is how to read the resistor value.
Right.
So this is relatively off the cuff, but you can go to a resistor value chart. This one looks pretty. how to read a resistor. We will have to make a nice article and put it on the microcenter community page, the knowledge base page. So basically, there's going to be any number of bands on the resistor.
Okay.
So let's take a look at the one you have in your right hand, and how many bands do we have?
I see 5. So
Okay.
I see 2 red, 2 black, and what looks like a brown.
Okay. So the way we're going to do this, go ahead and flip that over
Okay.
for your eyesight. The first 3 are going to kind of tell us the value, and then the last one is going to tell us basically plus or minus what % of accuracy.
Okay.
So what colors do you see?
See brown first. That's that first line. Definitely looks brown.
Nope, flip it. Sorry, flip it back
I'm
over.
gonna flip it back.
Yeah. Yep. Okay, so
There we
what
go.
do you see first?
Now I see red first.
Awesome. So red is 2. What's the second color?
Red,
Is also 2. What's the third color?
black,
Black. Okay, and then a multiplier is, or is there, let's see, what's the,
black.
another black, so times 1. So we had 220 times 1. 220.
Okay.
So that value of that resistor is 220 ohms. It provides resistance to the tune of 220 ohms. And let's look at that last band on there, which is gold,
brown.
copper, brown. Yeah.
Yeah, the brown.
So that means that the tolerance is plus or minus 1%.
Got it.
So we have a 220 ohm resistor plus or minus 1% of 220. So
Okay.
yeah, let's use those. Let's use some red, black resistors.
Well, fortunately for us, it looks like it came from this pack, so I have 5 total.
Let's start with that.
So I think we'll do 5 LEDs, right? Just to keep things simple across the
Yep.
board. I know we wanted to do 6.
That's fine. Actually, here's some more red, blacks.
Oh, are they the same?
Yep, I believe so. Or my
Red, black, brown. Yes, red, black, brown. Okay.
so a bunch of 220s.
Got it. All right, so then we can do our 6.
Yep.
So ohms, that's your resistance, right?
Yes.
I do remember a little bit about electricity, and that's your resistance. I guess hence the term resistor.
Yeah. Yeah, and the resistance is something you want to put into the circuit if you want to lower the voltage, bring it down. There's Ohm's law, which I don't feel adequately educated to educate you on that.
Right.
But it's V equals I times R. So voltage equals I, which is amperage.
Right.
Why it's not A, there's probably a reason. V equals I times R. R is
Right.
being resistance.
Okay.
So if you have 5 volts and you want to figure out what your amperage is, I, and you have a 220 ohm resistor, you would have to do some fun algebra, move the things around, and you would
Right.
get
As long as you have 2
answer.
of the variables, you can find the third.
Correct.
Can't do that one in my head, but I know that we could find that answer relatively easy.
Sure.
We should have a pen and paper when we do these. Maybe that'll help. We'll have,
Well,
we'll have a drawing board.
Yeah, I was thinking about like the iPad with the pencil, and then I could screen record that as well.
Ooh, we'll
Right.
do that in the next episode. Yeah,
Next
I think
episode.
we should do that. That'd actually be really cool. Okay, so we have to get the negative rail going, right?
Yep.
And so for that, that's going to come from where?
Any one of the grounds on the
Any
board.
one of the grounds?
And there's a handful on the shorter set, and there's also, I believe, one over on that one. So, yes, there you go.
And I'm plugging this. I'm using the ground on this side.
Yep.
I've got the negative over here.
Yep.
And I'm going to be a little proactive here. If I remember correctly, I could just take this cable, plug it in here.
Yes.
Not that we need it specifically for this circuit, but I can make a jumper. So now both rails are going to be negative.
Both negative rails are connected.
Right. Not that we need it, but they are connected.
Right.
Got it. Okay. So looking at the diagram, we'll have one end running from the negative So it looks like they're using jumpers from the negative rail to where it's plugged in.
You could, for the sake of efficiency and unnecessary cabling, we can plug the shorter end of the LED right into the negative rail.
So I have an LED right over here, right? So I've got the long end, short end. Fortunately, these are really long LEDs, so I'm just going to kind of probably bend it over a little bit. They're very malleable. And I'm plugging the shorter end into the negative
rail.
Well, I can see why they have jumpers, because I think
you got this.
If you want to be more delicate with your LEDs than what I'm doing here. Yeah, but look, it works. It's connected.
Yep.
I feel pretty good about that.
What I would do is I would skip maybe 2 spots.
Like space it out.
Yeah, space them out just a little bit.
So these aren't quite micro sized, right?
And actually, for the sake of the cabling, let's go ahead and actually use this rail. So transpose that guy over here, because that way when we run the cables to the positive, they won't
overlap.
Yeah.
I see. So if we do it on this side, because then negative, positive running that way. Got it.
It'll be just a little bit closer.
Let's do it that way. So I'll do this on number 6.
Yep, and try to keep all the positive leads in maybe B, in the column B.
And that's where navigation kind of comes in handy on the breadboard, right? Because column B, and then I see row 6, and then what I'm going to aim for is positive lead in. I'll skip maybe to 9.
Yep.
I'll do 9.
That sounds
B,
good.
And then I'll have this down to the negative over here.
And while you're doing that, I will go find some code. Now here's the thing with Arduino, because it's been out for so long, there are so many code examples, or sketches as they're called, out there on the internet. So I should be able to do a simple search for Arduino Larson LED code.
Refresh my memory. Short end goes where again? Negative?
Short end goes in the negative, correct.
There we go. Let me make sure I got that one right.
There it is, Cylon. That was the name of the
Cylon.
robot that I...
yeah.
So the Cylon Larson scanner. And it looks like it's out for debate on whether it's L-A-R-S-E-N or S-O-N. I think I saw more S-O-Ns. Now, as we're doing this, I want to touch on AI a little bit. We'll spend way more time utilizing it in future episodes. When I first started programming Arduino over a decade ago, it was very much you had the sketches you wanted built in, the basic sketches. You found something on the internet which wasn't nearly as populated as it is now, or you happen to have a really smart friend in a makerspace that could kind of get you there. No, it wasn't me at the time.
Well, you're my very smart friend.
Well, so it's way easier now, and almost to a fault. So I think what we want to address, because I'm going to go ahead and use AI here shortly, what we want to address is it's great to use AI, and honestly, it can be a heck of a time saver. But you still need to know a little bit of the theory. You need to know some of the terminology so that you can ask it the appropriate questions. And then you need to know how to talk to AI a little bit in terms of getting the results you want. All of that's a practice skill, but it's way quicker, fortunately and unfortunately, than the traditional way of learning to program some of these things. So with that said, I have on my screen here a Cylon Larson scanner fast LED sequence. And I could go ahead and copy this, but honestly, I don't know that this is going to fit my specific setup.
Yeah.
So before I jump over to the AI, let's take a look at the circuit so far. So you've got all the negatives in there.
Yeah, I have all the negatives attached on the negative rail here. All of the positives over here, spaced out kind of like every third space, roughly.
With this setup now, you have the negatives in the negative rail.
Right.
And you have the positive legs sitting in these rows. Let's use the resistors, not LEDs. Let's use the resistors to jump from the same row on this side of the breadboard to the row over here. Now, you can see there's a line going through it. That means that these are not inherently connected to these.
Okay.
So the row doesn't go the whole way across the board. It only goes to where this middle stop is.
Got it. Okay. Now, does the direction of the resistor matter?
No. So in this case, this component is the polarity does not matter.
Got it. Okay. So I have this in row 6. So I'll just plug it in to row 6 on this side, and then plug it into row 6 on this side. Nice and connected. Okay.
So while you do that, back to the piece about AI. Once you've learned some of the basics of Arduino, once you learn some of the terminology, it can be crazy efficient to do this in AI. So let's try this. I'm going to try to talk as conversational as possible. I need help. I need help generating an Arduino sketch for a Larson scanner. And it will comb the internet, obviously, and figure out what a Larson scanner is, or it already knows it. This will be on an Arduino Uno R3. So we're telling it what board we're using. That's very important because it's going to reference all of the sketches ever made for that. It's also going to reference the data sheets that are out there on the R3 and know how to handle different things. And we will be using pins. Let's see. If we start at 1 and we go to 6, we'll be using pins 1 to 6. Digital pins 1 through 6, and that's just clarifying that we're not using any of the analog pins. So we'll be using digital pins 1 through 6. Let me think if there's anything else we want to tell it. We have individual resistors connected via ground and a 220 ohm resistor. All right. We'll pause there. We'll come back here. So now that you've got that, we want to start using the jumper wires to go from that side of the resistors into pins 1 through 6.
Got it. Which one should be pin 1? I was kind of thinking, since we only had 5 blue LEDs, I thought the red could be like the end of the series or something.
Okay.
So should that be 6? Or it doesn't matter. We can just do it in software, right? Where we program.
Yes. Why don't you make that one 1 just so the jumpers are clean.
I'll space it, but I don't know. Okay, so I'll take this one, go from 1. All right, this part's relatively easy.
Yeah.
At least wiring it up. I think it's really just understanding the polarity of the LEDs, understanding sort of, you know, what's going on with the resistor, and really just paying attention to where you're plugging everything.
So back to the request for code. I think that should be enough to get started. And I'm going to hit enter and see what they come up with.
Let's see who's faster, the AI at generating the code or me plugging in these leads.
So I thought about this and it brought it up, which is very interesting. So it's important to know that digital pin 1 is actually also the TX pin for the RxTX, the transmission used for serial communication. So if you're uploading via USB, it's best to avoid using pin 1 unless necessary, or disconnect the LED on pin 1 while uploading to avoid interference. So,
I see. So there's a TX there, so that pin is used for what, the onboard LED here, this TX?
No, well, yes, it's used for, so serial communication has a transmit TX and a receive RX, right? So when it's uploading the code, basically what's going to happen is it's going to be sending things out against the board, and then the board's also going to talk back a little bit over USB.
Right.
Universal serial bus, right? So the problem we could run into is, depending on what type of component's hooked up to either pin 0 or pin 1, it might create interference, or it might not allow the communication to work smoothly.
Got it.
So we have two options. We can pull that out of 1 whenever we program it and then put it back. Or
I would just move everything up 1, right?
let's do that.
I mean, I would move this one up 1, but then I feel like it would be out of order, and I feel like logically I would want it to be 2 through 7.
Yep.
Rather than have it be like, 2 through 6, but 1 is on 7. So I'm shifting up all of these by 1 on the Arduino.
We'll talk through the code a little bit, but basically what I just asked ChatGPT to do was give me revised code for pins 2 to 7. It's doing that thing where it gives me multiple options for what I like, and I'm trying very quickly to understand what differences are there. And for the most part right now, it looks like it's primarily in the comments. Otherwise, the code is similar. So let's go ahead and copy this code. We are going to go back to our cloud editor. That's a clean circuit. That's a nice, clean-looking circuit. If I was being real nitpicky, I would move this ground over to this ground.
Thinking the same thing, because I do have
you and me both.
the cables like in between each other, which,
Oh, I thought you were going to say OCD.
well, it was irking me a little bit, but also I could live with it. Have you seen the PCs I've built? They're a little messy sometimes.
That's okay. Sketch not found. Oh no. Let's go to sketches. So what we're going to do is we are going to...
I gotta plug this guy in.
Not yet.
Not yet? Oh, okay.
I mean, you could.
Jumping ahead.
Yeah. Let's do one thing at a time, even though we were doing 2 things at a time before. It's all
Let's do
good.
4 things at a time.
Look at all these sketches. Andy's Playground 2 Melodies. Circuit Playground. That's a fun one. We'll get into that at some point.
Okay.
We are going to do a new sketch. Create new sketch. And let's double check that our Arduino client's still running down here, which it is. Go to Arduino client. Yep. Now, I'm going to go back to the AI, which I still have up. I'm going to copy the code here. I'm going to go back to the new sketch. I'm going to select everything and paste.
And one thing I want to call out really quick. So obviously we're using AI to help with some of these software bits. I think some episodes are going to be maybe a little more hardware focused, and some episodes might be a little bit more software focused. And we will dive into what some of these, because I want to understand sort of line by line what these things mean, right? But I think for today's episode, we're really just kind of focusing on the hardware concept itself and showing that AI can be a solution.
Yeah.
But I think what you're leaning into is that there's a base level of knowledge that you need to sort of start using AI as a tool.
Correct. AI is not a slouch when it comes to comments. It still does that. However, you can always add more comments in if you move things, test things, or try things. But let's just take a look at it really quick. And it's doing some setup stuff right here where it's saying, okay, here are the pins that I'm going to use. Now we plugged it into 2 through 7. Right. And then what it needs to do is it needs to create a variable that it keeps track of, right? Size of LED pins. Now, if we go back to LED pins, go back up here, and whether it's 2, 3, 4, 5 sides of LED pins, I think initiates at 0. I'll be honest, I'm not sure about that part, but and then the delay time is 100 milliseconds.
Okay.
So a tenth of a second, I think. Now, so that's all the setup part. I'm sorry, that's all the like naming things part. Now we get into a setup clause or a setup area where we're going to say for any time that I equals 0, I is less than LED count, I plus plus, meaning like add a number to that variable.
Okay.
We're saying that the pin mode is going to be an output, and we're saying we're going to digital write the output to low to turn off all the LEDs at startup. So this is going to run once when the code starts. The setup will run once.
Okay.
What runs over and over again is this loop section.
Got it.
So think about it. First, you're going to name some stuff. Then you are going to define some things and get it started. And then you're going to run through the loop. And the loop is basically saying sweep left to right using I as the counter or the math to go up. Turn on one LED. Sweep left to right, skip fast to double void flash, LED count is -2, math. It's doing math.
Mm-hmm.
And I just want to reiterate here, I'm not an expert on programming by any stretch of the imagination. So if I seem in over my head in explaining this, it's because you don't have to be like a seasoned programmer to do this. You can learn and read things and understand generally. And the nice thing about this is if something doesn't quite make sense, it doesn't hurt you to change that 2 to a 3 and see what happens.
Right.
You can always put it back. But on that note, try to only ever change maybe one variable at a time when you're first getting started.
Don't change them all.
Right.
Because then you won't be able to track what's going on.
So here it is. It's digital write LED pins low, meaning turn it off. Digital write LED pins index high, turn it on. I'll be honest, I don't know if this code's going to work. This is AI's attempt at this. There's probably an 85% chance that it will work. Mm-hmm. And if not, we will get an error code, which we can feed back into ChatGPT and say, hey, here's what I got. Now, I've done this enough times where the back and forth between the error codes and ChatGPT allow you to get very far very quickly.
Okay.
Because what it'll do is it'll go out and say, oh, he had this error. And then it'll say, okay, who else has had this error in the past and what was their resolution? Here's the modified code.
Right.
And it will explain it, but the fact that it just comes back to you with that. So let's suppose that this is going to work. Let's go ahead and plug in the Arduino Uno.
Alrighty.
And if everything works right, we should see that pop up right here, which it did.
Yep. See the little LED here, so it's on.
Yep. We've got it connected. We're going to go ahead and upload it. Again, the check mark is just to verify the code. Let's go ahead and do that just for the heck of it. Basically, it's going to run through the code and see if the compiler or the IDE sees anything weird, like missing a bracket or a variable that's defined but not called or vice versa. Done. So it looks like it's okay. We'll go ahead and upload it. I believe every time you upload it, it verifies anyways. So it's kind of redundant, but just so you know what those two buttons are.
All right, I'm anxious. I'm hoping.
I am too.
Let's see what we get. Yep, still loading. Uploading.
You see any data on the RxTX?
I am now. There it goes. Hey! Ho! Ho! Ho!
Look at that. All right?
Not bad.
Yeah. It's a circuit.
We got it on the first try. And there
Yeah.
we go.
Right? That's fun.
That is pretty cool.
But remember, it took knowing the right terms to be able to tell ChatGPT how to do it.
Right.
The better way probably is to use all the examples till you become an expert in the Arduino IDE. But
we're jumping around.
We jump around, and it's a new day, right? It's a new time for this stuff, and using AI to program is just kind of wild. I think I think the big thing here is that when I got started with all of this, programming was the bigger hurdle for me than the hardware.
Right.
And it's not that hardware is not difficult; it's hardware, but it was like I could hook LEDs up. That's just following, diagrams.
Right.
But without knowing how to code, it was very intimidating. It's really not anymore because of all the sketches and the examples that Arduino and any number of hundreds of thousands of people have put on the internet. You have reference for any number of things.
That's very cool. Yeah, this is pretty seamless all in all.
Yeah.
I mean, the trick with AI I have found is definitely you do need to ask the right questions. You almost need to know enough to ask the right questions. And now that we've come this far, I think we should ask it one more question because I want to add one little adjustment to this.
Yes.
Now, if I'm understanding this correctly, this little piece here seems like it plugs into here and it looks like it's a little dial.
Yes. That is called a potentiometer.
Potentiometer, there we go.
And it is a variable resistor. So what the potentiometer does is by turning the dial or adjusting the potentiometer, you adjust how much resistance is created.
Right.
So
how could we add this to this circuit? Or actually, let me back up. Is there a seamless way to just make a couple of modifications to add it to the circuit? And can we make some modifications to the code so that if 0 is here and 100 is here on the resistance, or how it's reading that resistance?
Yeah.
Right?
So yeah, there's multiple things you could do. You could do like make it light up the whole way, or you could have it adjust the speed of the scan, like how fast it goes back and forth.
Right. Okay.
So you just have to tell me, and we just have to ask ChatGPT, or honestly, the Arduino and this the original thing we pulled up from Tinkercad has that.
Ooh.
So we're really not that far off.
I didn't even realize that was on there. I logically just kind of ended up here, but I didn't realize it was already there. Okay, well then let's incorporate it. So what do we do to add this guy? It looks like...
Yeah, go ahead.
Well, okay, so there's 3 leads here.
Right.
Okay, and it seems like one of them is being jumped to this port. One of them's being jumped to this port, and one of them is on the negative.
Correct. So there's 3 things that you're going to connect.
Okay.
One is ground. So yeah, to your negative rail.
Okay.
The next one, the red, is actually I believe it's a 5-volt signal.
Oh, okay. I couldn't read it. It was real tiny.
Right. So you have...
there it is.
You have your ground that's hitting the bottom, one of the bottom legs. You have your 5-volt that's hitting the other bottom leg. And then you have A0, and we'll talk about what this is, hitting, I think it's considered a wiper, like what's going inside. It's like a little, it looks kind of like a little thing that's like tracking along a circle, which increases or decreases. So let's go ahead and wire that up. Let's see if we can do it based on this.
So it looks like they have it set jumping across like this. So I'll just plug it right into the board there. So I have the 2 pins on this side, the 1 pin on that side.
Let me double check that it's seated well.
I think
it does feel breadboard compatible. However, sometimes with certain components you really got to push in, or not. That would be sad, right?
It seems like it went in. I guess we could just plug it.
There we go.
Yeah?
I think so.
All right, I'm going to borrow from another kit too because we're running out of jumpers.
Oh, we need more jumpers. You can never have enough jumpers. On the topic of jumpers, right, these are considered male to male. It's always good to have male to male, male to female, and female to male. Have like a whole assortment of them.
Right.
Because you might be at a point where you really just need to plug in an LED and you don't want to mess with a breadboard.
So I do see that I have like a female to male.
Yeah.
So I could potentially put the potentiometer into just these.
Potentially, yes.
But I didn't want to have it loose
Right.
right? I want it on the board so at least it has some stiffness.
Yep.
And I grabbed some of the longer ones. So, okay. Does it matter which one goes to the 5-volt?
I'm going to say no. I could be wrong.
Well, it seems, from what I can see in the diagram, it seems like the left one.
The left one will go to 5 volts, yeah. And if you want to be kind of persnickety, anytime I'm doing something with power, I would use a red jumper if you had it.
Oh, right. So color coding jumpers, I think, is another thing. I was going to ask about that. I mean, right now it's kind of a mishmash.
It doesn't matter.
Right.
But anytime you're doing, like, if you want to differentiate between 5 volt and ground, red is typically 5 volt, black or green is typically ground.
And
But we're okay.
I'm gonna break your OCD a little bit because I'm just gonna run it straight into that 5 volt in there.
That's right.
So the single pin at the top, right?
Yep.
This different pin, I'm gonna plug it into the same row. So I have this plugged into the row of one of the pins, and get it as close of a shot as you can get. I have the other pin. I'm gonna go to the A0, which is running over here.
Yep.
And then the last one is just going to ground, which, since I'm already this messy, I'm just going to use the ground over here. So now I'm going to take a shot in the dark, and we're going to say that sorry, I want to get that plugged in first. When I was asking about the potentiometer, right?
Yep.
My initial thought was that we were going to have it run in the circuit to control
Where it goes.
Yeah, like I thought it would be in the circuit itself that we've created where it's completing, this circuit here. But it seems like this is completely separate from that, and it's actually the controller that's reading what this is saying, and then it's outputting to this. So the controller is handling those, like the input of that, the output of that. I guess analog would be, this would be in series in the circuit. Am I explaining that right? Like if we didn't have the Arduino board, and if we were just doing this with like a battery and some other stuff.
Oh.
Right? Like that's what I thought we were going to do originally. Like the potentiometer would be in this circuit.
And no, so if you took the Arduino out of it,
right,
and just put the potentiometer in the circuit, maybe across ground, you could adjust brightness over all the LEDs.
I guess, yeah, that's all you could really get, because the resistance would be allowing less or more electricity to flow through.
Right. However, if you had something like a 555 timer chip, a small integrated circuit, that could act as kind of a timer. Now, the only thing I don't know offhand what that circuit would look like in terms of like addressing 6 LEDs. That's where the microcontrollers come in, where they have 13 digital inputs and outputs, and then another 5 or 6 analog inputs and outputs.
Right.
That I think the analog can also act as digital. So technically, you could hook up 13 plus 6, so 19, actually 20, because 0 is available too. So you could have 20 LEDs and have a Larson scanner that does 20.
Right.
That would take up all your pins and time. So we don't want to do that.
Right. That tracks. Okay.
So, but in this instance, you're saying, is it inside the circuit, or is it inside with the LEDs? It's kind of not. It's its own controller talking to what is the microprocessor or microcontroller processor here to affect multiple other things in timing. So what we need to do now is decide what we want it to do. Do we want it to do speed, or do we want it to do like a VU meter where you turn it up and all the lights go up, and you turn it down, all the lights go off?
Let's try speed.
Okay.
Let's start with speed, and then we'll go from there. Eventually, what I would like to try maybe after that, because I feel like hardware-wise we're set. Maybe it's just a software thing, but I think after speed, what I would like to try is to see if we could dial in individual LEDs. So I guess the resistance range would be like, if this is 0, 20%, 40%, 60%, 80%, 100%. Right, and then we can dial in each LED, and then
do you want a single LED lit at a time?
Yeah.
Okay, so you get to play the Larson scanner.
Exactly.
I got you.
That's what I was thinking.
Okay, so let's do the speed first, then we'll do that.
Right.
And I'm
Because AI is fast enough. We can do both.
yeah, I'm relatively confident we have the mental capacity to do both. So let's say we've added a small potentiometer. Now, potentiometers come in various resistances, or various like 0 to
Right.
10K. I'm gonna
I
guess.
saw 10K.
Did you?
I was going to ask about that. 10K
Okay.
was written on the potentiometer. I did see that. I meant to ask.
So let's add that in, because that has some weight on what we're doing. We've added a small
10K. Yeah, on the side.
potentiometer with 10K. We would like to be able to adjust the speed of the Larson. That should be more than enough. Well, no, it will ask me.
Do you have to tell it what we did, though?
Yep.
I feel like you should explain to it where we plugged everything.
Yeah. It actually suggested what we did.
Wiring the potentiometer. So it's telling
To
us.
A0, yeah.
Because that is what we did.
Right.
It's probably looking at the same link we were looking at in the other.
It's the logical thing to do. So
Why are we teaching this? Just have GPT do it for us, right?
well, yes. So be careful not to get too trigger happy with copying the code. Make sure that it's completed, and then you can copy it. I've done it before where I'm only halfway through the code because it's still thinking about it. I'm like, oh, great, copy. And it doesn't work.
Right.
So you want to make sure to give it ample time to create the code.
Because it is updating that response in real time.
And let's see what is different. So we're still doing 2 through 7. We're still creating a variable for LED count. The potentiometer pin is new, and that's on A0.
Zero, yeah.
And then we have the minimum delay is 30 milliseconds up to 300 milliseconds. So that's the range of speed that we'll get, which at 30, my guess is it's going to be pretty fast and almost look like a blur. Now we've got the setup, pin mode, LED pins. What's interesting, okay, here's the pot pin. The potentiometer pin is an input. So like we talked about last time, this is our first, I think, instance of mechanical input to, let's say, digital output, or real world input to real world output.
Right, okay.
So input output, that's going to be big for as we progress through these projects. We want to know how to do that. Let's see, read the potentiometer speed and delay time. Speed left to right, the LED light on, delay time. Speed right to left, one LED at a time. Yeah. So basically, this last part is probably the most important part, in my mind at least. It's going to take the smallest value, so 0 resistance, to the highest value, 10,000 resistance, and it's going to create what's called a map. And it's going to say at 0, it equals 0. Easy enough, right? But at 10K, it actually equals 1023 at the highest one. So that's the value it can output.
Okay.
In other things, it's 0 to 256, like in color, like RGBs.
Right.
In MIDI, music instrument digital interface, it's 0 to 127. So you have 128 like scale.
Okay.
In the case of this, we have a scale that goes from 0 to 123, or it's 1024.
1020,
basically,
right.
because 0 is a number.
Right.
So, assuming we did this, let's go ahead and copy this. There's so many little bits and little nuggets that you kind of have to internalize for all this to add up. Control A, Control V. We've copied, we've pasted. There's our read pot speed.
Right.
And we are going to go upload.
Full send. Let's just send it right in there.
Yep.
Verifying. All right, cool.
Now, I don't know what's going to happen out of the gate. I could look at the code and say out of the gate it's going to not even be turning, but we don't know where that... out of the gate,
slow.
it's reading it. Yeah. Because
Okay.
we didn't set the pot to 0. What happens if you turn the pot the whole way counterclockwise?
Well, it's going clockwise now because that's all we have. So that's full clockwise.
Okay, so at full counterclockwise, it was just really slow.
Yeah, because I have it turned all the way counterclockwise.
That's
so
the
that's
300 millimeters per second. Or sorry, yeah, 300
milliseconds. You got 3D printers on the brain.
Yeah.
So then I can just dial it up. So that's me turning it like maybe a third of the way.
Mm-hmm.
Do another third. And then full send. Look at that.
What's interesting is it almost seemed like there was a ramp built in, like it didn't go directly to.
Yeah, it seems like there's a little bit of a slight delay from when I change it to when it like registers to do it.
Well, and the reason for that is it has to finish the loop.
Oh, interesting. So it'll do it on the next loop.
Yeah, there's less of a delay the faster it gets because it's finishing.
Right.
It's going the whole way through the cycle.
But as you do it slow, it has to finish that loop before.
That's my theory.
Well, let's test your theory. I'm going to have it set to 0. So it started a new loop. I cranked it to 100. There it goes. So once it got to the end, then it went. So there. I cranked it up. Yep. So it's starting here.
Yep.
And then it's coming back. Uh-huh.
How fast does it go if it's going fast to go the whole way down? It should be instantaneous almost. Yeah.
Yeah, it is basically instantaneous. I have to like catch it right.
Right.
Interesting. Okay.
So now you want to address them and select them essentially.
Yeah, I think that's the next step for us. So we've got the speed bit.
Yep. So we will first give thanks for that previous code.
Thank you, ChatGPT.
When you all take over, just remember,
We thanked you.
we were the nice ones. Thanks for the precious code. Oh, previous code. It's also precious. Thanks for the previous code. We would now, like, there was that scene in Charlie and the Chocolate Factory. I don't know if you remember this. They had this like large room-sized computer, and it was trying to do like the science between like where the box of chocolate
Oh,
was.
yeah. What would a computer do with a box of chocolate?
Yeah, it's like now I will tell the computer exactly what it can do with a box of chocolate.
That's one of my favorite scenes.
Yeah. Thanks for the previous code. We would now like to use the potentiometer to turn on and off a single LED in a row, i.e. basically controlling the scanner one LED at a time by rotating the pot. It's kind of, that's trying to describe that was difficult. So we'll
Right.
see how it does. Potentiometer selects active LED. There's not going to be a ton of difference in the code.
I would get granular and even say that I want 0 on the potentiometer to be
Pin 1.
pin 7. And I want 100 to be pin 2. Because I want 100 to be that red.
Okay.
Because I want to go from like, like,
Let's see what it gave us,
Red
and
is
then
like
let's
100.
go edit that if we need to. Let's see what it did. Control A. We're going to just get real fast at programming here.
lightning fast. All right, so I think full counterclockwise is 0. Well, let's just see what happens.
Console uploading. Should see the TXRX dance.
There goes. Okay.
Try
Nothing.
turning it.
So, oh wait. Okay, there's 1. 2. Wait, I think I gotta find a sweet spot. No? Right. Okay, so that's max.
Oh.
There's that one. Yeah, this is kind of what I wanted. This is what I wanted. That second one's hard to find. I feel like I have to dial in an exact resistance. Because now I'm at 0 and now it's doing nothing. Interesting.
So,
Oh wait, then it just jumped to 100.
let's talk to our friend. So this is a bit sketchy. See what I did there? She does, because I have a female voice, it's a she. I see what you did there. That was brilliantly resistor and to sub. Oh, you tried.
Really?
Clamp the range to stay with an array bounds. Let me clean up the sketchiness in the sketch. You're probably seeing inconsistent behavior because the map of the pot value. That's insane because I didn't even tell her why.
You didn't even explain what was wrong, but I already figured out that.
Yeah.
All right. Fine. Full send. Let's just slap it in there and just see what happens.
Yep.
Episode 2. We're just going lightning speed. But I do mean it. In a future episode, we are going to go more programmatically about.
Yeah.
I want to get a little granular on sort of like what the lines of code mean. I'm definitely catching on when you're like walking me through it here.
Yeah.
It's going to take me a little bit to really get into it.
I mean, I can only explain it to the level I can explain it after a decade of doing it. Like,
right.
And I don't think I'm explaining it correctly half the time. So it's through practice.
Right.
It's through seeing things over and over again, doing different projects and different examples that utilize a potentiometer or that utilize multiple digital outputs, right? Until it's like anything in life, you can learn it, you can study the theory, but until you have the practical experience, things don't always register.
Right. No, I agree. We'll figure it out by doing. And maybe you will too. All right, so I have it set to 0. All right, this is smoother. Oh, it jumped to 100. Oh, but I think that's because I'm like rocking I think the connection of the potentiometer on the breadboard is a little.
I agree. I
janky.
didn't feel great about it being seated in there. Yeah, because if you pull it out right now, where would it go?
Oh,
there.
But this is what I wanted. Because then I can it's jumping because I can feel the potentiometer is like losing connection on the breadboard because we kind of shoved it in there. But this is what I wanted. I wanted to be able to be like. Let me see if I can just
Yeah, because it goes back.
So this could be a hardware problem.
Well, let's try this.
It could be a software problem.
I think it's hardware. So what I think we should do is actually let's go ahead and pull that out and let's find those female to male. Because I think we're going to have better luck.
Did I put one there?
Here's one.
I have one here. I have cables everywhere.
That's the ground or positive, it doesn't matter.
Grab some from here.
We just need one more.
Just one?
Whatever that one in your hand
Well, I got
probably.
These are all male to male. Hold on.
What are those?
Which one? These male to male, male to male.
Oh, bugger.
This looks like it's part of a motor, which we'll touch on later.
Well, let's make it super. I wonder if that works.
Does that really work?
No, I don't know.
Just touch it to the thing.
Yeah, we're gonna touch it to the thing, and then. So, here's the thing: 5 volts isn't dangerous.
Path of least resistance. I know that much. And your body.
There you go.
Fairly resistant. That's what I was looking for. There it is.
There is going to be a point where
it's going to jump.
Yeah, there's noise, right? There's noise in any circuit, but it's like you're just at that value that's like jumpy. Let me see if I can get the next one to jump.
There it is.
Yay!
So you're hitting a spot where like that. Is it that 1%?
Yeah,
difference in the resistor, or is it that interesting?
I mean, the other thing you could do is you could have separations. Like you could basically tell the map that like, okay, remember where the map goes from 0 to 123.
Mm-hmm.
You could say 0 to 200 is the first LED.
Right.
260 to 360 or whatever is the next LED, but you have that gap in there that's nothing.
Because if it's 220 and 221, and if it's jumping between the two, that's why it's triggering both of them. So you're saying put a gap there, like a buffer.
Yeah.
For the input. Okay, I get you.
Now you could have a section though in that scenario where you have nothing on. If you dial it right into that.
Yeah, because it'll be like on off.
Yep.
On off. On off. There it is. You are the Larson scanner.
Yes, you are.
That's awesome. This looks really cool. I like this.
Yeah. I mean, here's the thing. This is all fun and fine, but what good is it? Past education, right? Like
Right.
past learning this. I mean, is there a practical need for something like this? And to my mind, it comes to like maybe a status indicator. Like if you have 5 instances of something happening like pictorially on a wall,
Right.
and you wanted to light up any one of the 5 or 6 items, like backlight it. Like right now, we're in focus mode. Right now, we're on a call in a meeting. Right now, I mean, sure, you could just use an iPad and a screen and whatever, but
Right.
you could, this is, and then, you know, whenever you're changing status of whatever you're doing, you just walk over and you turn a knob till you get to the status you want
Right.
to light up.
So for this kind of input, you're kind of rocking it in between all the different lights, but this setup is exactly the same as if we wanted 6 little signs to light up and say something. But I think if we wanted to get, I think a better input would be a switch for each LED.
Sure.
Right? But that's a whole different setup.
Sure. Yeah. And you can have a switch for each LED or a single switch that cycles through lighting each one up and then down.
Right, because you could ding, 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 ding.
Yep.
Which we do have some switches, and I think we can dive into that in the next episode.
Yep. That's just another input.
I like the very nice tactile feedback on that. That sounds good. Some nice Arduino ASMR. Well, I think that's a good stopping point for today, right? Because I wanted to take sort of what we covered in our first episode, and we really just touched a little bit on some things. I think today we really just jumped right in head first.
Yeah.
But I think going from here, we can start looking at maybe LEDs and a couple of different, other setups. We could try out a couple of different other inputs. I want to do a whole few episodes just on motors, and that's a whole other thing that we're going to get into, because motors, there's a lot to cover, right? But this is cool. I like this, and it's running a lot better in your hand than it was on the breadboard. So that's another thing. How do we address that?
We would we would probably source a better potentiometer for breadboards, or potentially even a circuit that's. I mean, what these are meant for is through-hole soldering, so on an actual PCB. So for this, ideally it would go in there and just kind of sit flush and go where it needs to go. But because it's not necessarily meant for breadboards per se, you're going to have that issue,
right?
Where you're going to get the noise if you don't.
Right.
But yeah, there's so many things to troubleshoot, right, on any given project. So always check your code, always check your hardware, always check your connections, check your polarity, whether the component is incorrectly. If we don't have this incorrectly, what happens?
I had to check it numerous times, by the way, because I kept forgetting which was negative and positive.
Does it burn out? Maybe. I mean, it just doesn't light up if we take it there. Pretty sure.
Yep. It's not on.
Does it get warm, though? Nope. We'll find some time in one of the upcoming episodes to create some magic smoke. That's always fun.
And how you can burn an LED.
Nope, capacitor.
Oh.
It smells like
Don't those pop?
Yep. We'll
do it in a controlled environment,
Sure. What's the cereal that has the frog on it?
Oh, is that Smacks?
Yeah, Smacks. It smells like Smacks. It's wild.
That's weird.
Yeah.
Like sugary.
Like barley oaty. Yeah.
I haven't had corn pops in a long time. Kind of craving that now. I'm hungry.
Yeah. It's past lunch.
It's lunchtime. All right, well, tune in on the next episode. We're going to cover more on our Intro to Electronics series. As always, Andy, this has been great.
Yeah,
thank you.
Fun.
I feel like I've actually learned a lot here today. And we'll catch you in the next one.
See ya.